This is the final iteration, at least I hope it is, of my single battery voltage reference board. I elected to use an REF 5050, which is a 5-volt output. The manufacturer, Texas Instruments, recommends this method of trimming. Essentially a 10K resistor connected across from V out to ground with the wiper going to the trimmer. I don't know what this 1K does. I could see if it was no resistor here that it could keep me from pulling this down to 0, but this is a 470K, so I mean I'm not going to pull it down to 0. In any event, something like this is what the manufacturer recommends. I looked at both the DMM check and the VREF-01, and they are 5-volt commercial standards. And of course, this is a replication of Texas Instruments. Both of them use this sort of arrangement. Okay, so this resistor, say that's the same. I don't care if we're talking about 18K out of 500, it's trivial. Then they use this ratio of resistors and a 500 ohm pot. I ended up using a 6.49 and a 20.8 because that's what I had in my RN55 series resistor. And then I used a 1K pot because I didn't have a 500 ohm pot. I probably should have reduced each of these according to their percentage when I increased the resistance of this pot, but what the hell. And of course, I think this is a SOT8 base device, so I used an adapter board. Now what I've done on both the 2 battery and the single battery is I put 4 additional holes moved over 1/10 of an inch to allow for the use of an adapter board, because the adapter board doesn't develop the footprint of a DIP 8 or a 4-pin dual configuration. Now these are entirely wired in parallel, and I screwed up the silk screening on this reverse voltage connection diode. I screwed it up. Anyway, even with a 1,000 ohm potentiometer, this thing is a pleasure to adjust. Looking at my Hewlett-Packard voltmeter, I mean, it's just so easy. I'm sure if I had put a 500 ohm pot in, which would be 2 times less sensitive, or half as sensitive as the 1K pot. Works very nicely. I've burned this in for about a week. And this battery's about ready to be replaced. I think the main current consumers may be this LED, and you can make it as dim as you want by increasing the value of R5. There's no sense making a current hog if you're going to do a battery. But I looked at the VREF-01. I purchased that from Maloney Electronics, and he has an LED and some sort of a series resistor. Now this board is essentially only good for a 5-volt reference, and we figured we might be draining the battery down to 8 volts. The reverse drop across this diode, or the forward drop against this reverse protection diode, is a half a volt or better. So you're losing a half a volt here. So this chip has to be able to have an input voltage of around 7 volts. I did use a AD586 in this configuration, and with a brand new battery it was able to be calibrated. At that time I did not have this additional 0.6 volt or 0.5 volt drop, but it wasn't very long as the battery went down that this thing went to hell, because the recommended input voltage for the AD586 is 9 volts or 10 volts. It's something, yeah, it wants 10.8 volts. So, I mean, no way. However, this 5050 only needs an input voltage of 5.2 volts. And maybe I could use the Max series, which have minimum input voltage of somewhere around 8 volts. This one only requires 5 volts, but its output is only 4.096. And I have one of these. I may just go ahead and use it. It's an REF 5040. But the 5 volt references that I think I could get away with would be the REF 5050 or 5. Well, they make a 5050. So I could probably use the 5020. That's a 2 volt. The whole way. I could not use the RF 5010 because that will have an input voltage minimum of 10.2 volts or more. If I were going to build a standard, a reference, and I had a good meter to calibrate it with, one that was not 16 years out of calibration, 17 years, I think I would use this chip. And apparently Malone Electronics and the company that manufactured the DMM, which I'm suspiciously thinking is probably Doug Malone in each case, uses this device. And both of these devices have these resistors in them, if I'm reading the colors right. The only other thing about the 5050, every other voltage chip I've used, turning this pot clockwise increases the output voltage. Does not seem to be true for the 5050. It's a reverse acting pot. Go figure. So let's talk about voltage references that you can buy that are recalibratable or re-standardized. You can buy the fixed ones from China, or you can buy fixed chips and use the guaranteed output voltage without adjustment. I found 3 of these. I know there's a 4th one out there. These 2 are made by Malone Electronics. This is a 5 volt standard, 0.01% accuracy. It's recalibratable or recertified, whatever word you want to use. And recertification, recalibration is very inexpensive. This costs I think $50 plus shipping, plus tax. It has a LED indicator. It's got a reverse diode, so it keeps you from sticking the battery in backwards and successfully burning the chip up. This is also a Malone product. It cost a little less than $100 delivered. It cost actually $95.10 delivered. This one is 0.0025 for a minimum of 6 months. 0.01, 0.0025. I guess I should say without this little plastic top, it's $15 cheaper. And I believe both of them can be recalibrated. Yeah, read this. All right. So he'll recalibrate this one for $10 plus shipping. And he'll really recalibrate this one. Same thing, 2 years free. Afterwards, calibration is $5 plus shipping. One I don't have paperwork for is the DMM standard device, and it's a voltage standard, a current standard, a resistance standard. I think the version that is out now has an inductor on it. So it's more than just a voltage reference standard. I bought one years ago that just was a 5 volt, 1 milliamp, and 3 standard resistors. But that's Model 1, I guess, and no longer is in use. It's not this one, it's another one. And the last one I want to talk about, you can find this one on eBay. I crossed the price out because I'm going to badmouth this without knowing the facts, I guess. It's a little plastic box with banana posts for both input and output, so there's no power supply supplied with this. It's a 10 volt standard. Then he goes through pages and pages, on his eBay page, of telling people how good this thing is. Actually, I have a photograph here that I took from a YouTube video from Solcom. I don't know how to pronounce the man's name. Now, it's number 8. He's been around for 5 years, so number 8's pretty old. This photograph was taken at 30 minutes, almost 31 minutes into his presentation. I believe in this presentation he went over 3 modules. And you can see at one point in time, this was constructed on perf board. It has, I think that's a diode maybe, or an LED, I don't know what it is. 2 resistors and a capacitor, and then the calibration pot. Calibration pot is accessed through this little paper dot. You peel it off and recertify it. There's all kinds of big long numbers, lots of decimal points. I can't see, maybe I'm missing it. Oh, here we go. Calibration is $40. And it's actually, the recalibration is sold through eBay. So we've got, this is the second page. There is yet a third page. But this particular one is, I'll say this, it's $33 for 12 months. If you want to make time payments on it. So those are four, at least descriptions of four, recertifiable or re-standardized or recalibration able standards. After going through all of this, and probably I'm not done with it, I'd buy one of these from Malone Electronics. I don't know the man, never talked to him, never emailed him. He has emailed me, I will say. Every time I placed an order for this one or this one, almost within 12 hours, he responds with an email telling me when I can expect delivery. For the average hobbyist, this is the way to go if you want a standard. Now I'll do a comparison of all these standards with a whole selection of meters in one of my next videos. If you can afford or need the extra precision, I would buy this. Well, I did buy it. $100.